Hey, Flipped Chemistry, how you doing? You ready for another Flipped lecture? We're going to jump into it. We're talking still about Chapter 18, but now we're looking at things other than carbon and hydrogen. What happens when there's more to a molecule than just carbon and hydrogen and single bonds? We're going to look at different kinds of parts of a molecule that can be stuck onto the side of a chain and can affect the way that it behaves. These are called functional groups. Let's jump right into it. This is not a sprint. This is going to be more like a marathon. So we're going to be slogging through quite a few concepts here. You got to pace yourself and stay with it. Here we go. A functional group is a portion of a hydrocarbon where a specific group replaces a hydrogen or a carbon and leaves the molecule radically different. So yeah, a regular just straight chain of hydrocarbons is not very exciting chemically. You can burn it and it might dissolve nonpolar molecules, but that's about it. It's not a very exciting thing. But you start to take off these hydrogens and put other things on there, and it gets real exciting. I know. You can hardly contain yourself with all the energy. There are three kinds of these functional groups. One of them is called an alkyl side chain. Alkyl, we're talking about alkenes, alkanes, and alkynes. And so if you take a hydrocarbon and stick it onto another hydrocarbon, and you just have hydrogens and carbons, you're not very exciting, but you do at least have a branching molecule, and that branching side chain is called an alkyl group. Okay. You can also have functional side chains where you've taken off a hydrogen and you've stuck something other than a hydrogen on there. Those are functional side groups. We'll walk through several examples of those. And then you can have main chain functional groups where carbon, 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 something else. Carbon, 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 carbon. And the functional group sits on the main chain of carbons. Okay? So here we go. Let's look at a couple examples of this. In alkyl group, we name just like the main chain. But instead we put "-il" at the end, and then that "-il" tells us that this is something hanging off the side. And then we have to number where the thing is hanging off the side. We have to count the carbons, and we have to number where the side group is. But we always want to count starting at the end. That is going to give us the smallest total numbers. So this is 3-methylpentane because 1, 2, 3, the third carbon has a methyl group, 1 carbon, right? And its associated hydrogens. So 3-methyl doesn't mean it has 3 methyl groups. It means that on the third carbon, there's a methyl group. It doesn't matter in this particular instance which way I count, because this is 1, 2, 3 as well. But 2-methylpentane, still 5 carbons in a row, and then 1 carbon hanging off the side. But this one is off the second carbon, so it's 1, 2-methyl. It would be incorrect to call this 4-methyl. 1, 2, 3, 4. We don't want to do that. We want to count from the side that gives us the smallest total number of carbons that we have to number and name. So what's this called? This is 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in the longest chain. So that's what? That's known. These are all single bonds, so it's nonane. And then if I count from this end, I have 1, 2, 3, 4, 5. If I count from this end, I have 1, 2, 3, 4, 5, 6. So I'm going to go from this side. I'm going to say it's 4-ethyl, 5-methyl, nonane. Okay, replay that if you don't understand. Here's another one. 1, 2, 3, 4, 5. Carbons in the main chain. 5 is pent. These are all single bonds. Pentane. This carbon has 2 methyl groups on it. So this is dimethyl. This is 2,2-dimethyl. But then along comes another one here. So I could have 1, 2, 3, 4. I could have 2, 2, 4. Or I could have 2, 4, 4. 2, 2, 4 is smaller than 4, 4, 2. So I have 2, 2, 4 trimethyl pentane. Okay, here we go. One more time. 1, 2, 3, 4, 5, 6, 7 carbons in the main chain. And if I were to turn here, 1, 2, 3, 4, 5, 6. So 7 is the longest chain. 7 carbons is hept. This is heptyne, though, because there is a triple bond. I have to label this as pent 2. Counting from here is smaller than counting from here. Pent 2-ine. Pent, because there's 5 carbons. Wait, did I say pent? I meant hept. 1, 2, 3, 4, 5, 6, 7. Hept 2-ine. So that's the main chain. But if this is 1, 2, 3, 4, I have 4-ethyl, 4-methyl, pent 2-ine. 4-methyl, 4-ethyl, hept. I kept saying pent. Hept 2-ine. Sorry about that. Functional side chains. Now, let's look at these. These are things that hang off the side of a molecule and are not just carbon and oxygen. So, carbon and hydrogen. I keep misspeaking. Here we have the rest of the molecule. This R group just means the rest of the molecule. Carbons and hydrogens over here. Okay? And then we have an oxygen and a hydrogen. The oxygen only gets to make 2 bonds. So one of them goes to the rest of the molecule. One of them goes to a hydrogen. This OH group is called an alcohol. And alcohols can be terminal, or they can be in the middle of the chain somewhere. We number them, and we say all at the end. So if this were on the 4th carbon, it would be whatever, and then for all at the end. Okay. These are really good for dissolving polarized molecules. They make a very nonpolar molecule, a hydrocarbon, slightly polar, and they are good as solvents, right? They're also good for biological fixatives. Things with this group tend to kill living systems. Halides, we just number its position and we say chlorine or bromine or iodine or whatever it is. That's pretty boring. A ketone. This is a carbon somewhere in the chain, and it has carbons on this side and carbons on this side. It is not terminal. It's somewhere in the middle, and that carbon doesn't have any hydrogens on it. It's double bound to an oxygen. So that's a ketone like this one. And we number ketones, and then we say "one" at the end. So this is 1, 2, 3, 4 carbons. If I start counting from this end, this carbon is 2. So this is butane 2-one, because on the 2nd carbon, there's a ketone group. Butane 2-one. Okay? Butane 2-one. Butane 2-one. Here I have 1, 2, 3 carbons, and the middle one, carbon 2, has a ketone group. So this is propan 2-one. Okay, propan 2-one. Now, in this particular instance, it doesn't matter which side you're counting from, right? Because I could say 1, 2, or I could say 1, 2. This is a symmetrical molecule. In symmetrical molecules, if you're talking about something in the middle, you can say iso, and that means right in the middle. So isopropanone would be another way of naming this. Okay. All right. Here I have 2 carbons, so that's F, all single bonds, so that's ethane. And then one of them, and it doesn't matter which one it is because it's the 1st carbon, and then if you want to count from the other side, this molecule can flip around. So I didn't really have to number it. This is ethane, and this is ethanol, so this would be called ethanol. This is drinking alcohol, by the way. Okay. Here I have 1, 2, 3, 4, 5 carbons in the main chain. I have a methyl group hanging off of the 3rd carbon, and I have an alcohol group hanging off of the 2nd carbon. You name this. Pause the video. Think about it. The answer is pentan 2-all. Okay? 1, 2, 3, 4, 5. Pent. Oh, it should be 3-methyl pentan 2-all. That's a mistake. It should be 3-methyl pentan 2-all. The alcohol is on the 2nd carbon. The methyl group is on the 3rd. 3-methyl pentan 2-all. Okay. You can have aldehydes as well. Aldehydes are just like ketones, but they're at the terminal carbon, so you don't have to name them because it's the last carbon. You have to count at the carbon away from the one that has the aldehyde group. The aldehyde has to wind up at the end. Okay? So it's exactly like ketones, but on the terminal carbon. We just say al at the end, and then we don't have to count. So you're making progress on this marathon. How you doing? Main chain ethers. We'll get to some names in a minute. Here we have the rest of the molecule, and then an oxygen, and then the rest of the molecule. So this is not terminal. This is somewhere in the middle of the carbon chain, and there's an oxygen instead of carbon. So there's no hydrogen here, and these are somewhat polar bonds, and it's not symmetrical. So ethers tend to add some polarity to a nonpolar molecule. They replace a carbon in the chain with an oxygen, and we name both sides independently, and we say ol at the end, and then we say ether. So if this had 2 and this had 4, then this would be ethyl butyl ether. Okay, that's how we do that. Carboxylic acids. Terminal carbon. It's the last one in the chain, and it has this carbon has no hydrogen on it. It's double bound to one oxygen, single bound to another oxygen, and that oxygen has a hydrogen. So COOH. Sometimes you'll see it written out that way. This is carboxylic acid. This behaves like an acid because this hydrogen can ionize off, and it can become a proton donor like an acid. So carboxylic acids, we end this by saying oic acid at the end. We don't have to number it because it's always the terminal carbon. Okay, so let's do some practice. COCC. 1 carbon, 2 carbons. This is methyl ethyl ether. Okay, methyl ethyl ether. This one, 1, 2, 3, and then a methyl group, and then 1. Oops, just kidding. So this is methyl, 1, 2, 3, propyl, but the propyl is 1 methyl. So this is methyl, 1 methyl, propyl, ether. Methyl, propyl, methyl ether. Yeah, there should be probably a 1 there. Okay, here I have 1, 2, 3, 4, 5 carbons, and then that 5th carbon is part of the carboxylic acid group. So this would be pentanoic acid. Okay, here's one. Can you draw this? Given this name, pause the video, draw that. It would look like this. It is heptane, so start with a chain of 6 carbons. Sorry, 7 carbons. 1, 2, 3, 4, 5, 6, 7. 3, 4, 6 trimethyl on the 3rd one. 1, 2, 3. On the 4th one, and on the 6th one, put a methyl group. 1, 2, 3 methyl groups. Heptane 2-one, so on the 2nd carbon, put a ketone group. And then oic acid at the end, make a carboxylic acid group. You could have had this exact same thing drawn flipped, that would have been fine. This is 3, 4, 6 trimethyl heptane 2-one oic acid. Good times. Esters. These are not queens of Persia. Just like carboxylic acids, where it's COOH, but the last H has been taken off and another carbon chain continues there. So this interrupts a carbon chain with a carboxylic acid looking unit. And an ester has 1 carbon that's double bonded to an oxygen and then single bonded to another oxygen, and then that oxygen goes on with the carbon chain. Okay? These things tend to smell good. Something about the way these things interact with our nerves and our noses and our brain. We tend to think that esters smell good. So they tend to be used as perfumes, and they're also frequently used as flavorings in food. Okay? We name them by naming the oxygen side of the molecule, this side, first, and then we say ol. And then we name this side of the molecule, and then we say O8. O8 means this was in there. So it's like an ether where you name one side and then the other and say ether. You name one side and then the other and you say O8. So this is 1, 2, ethyl. 1, 2, 3, 4, butanoate. Ethyl butanoate. Okay? What's this one? Take a moment. Pause the video and do your best. This is propyl heptanoate. Propyl because 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7. Propyl heptanoate. Okay? Last couple of them, nitrogen functional groups. We can have a nitrogen replace a carbon, and it can be either hanging out on the side or it can be in the main chain. When a nitrogen replaces a carbon, we call it an amine group. And we will say amine, and we'll number where it is. Okay, and so the nitrogen can be hanging off the side, and it would be like carbon, nitrogen, 2 hydrogens, or we could have a chain of carbons, put a nitrogen in there, and then keep the chain going and have 1 hydrogen hanging off the bottom. Either way, we call that an amine. Now, if a nitrogen group replaces an alcohol of a carboxylic acid, so you have C double bonded to an O and then an NH2, that we call an amino acid, and that is a very important functional group. This is the foundational unit of proteins. So you are done. Congratulations, you made it through the list. Your book has pictures and more descriptions, and you can look through that. Make any questions in the comments field below, or see me tomorrow, and we will go through them together. God bless you. Jesus loves you, and so do I.